any case, we are going to record it. If any case anyone wants the link to download the video afterwards, you can ask us. So, well, we are going to continue with this cycle of seminars. Well, first of all, if you have any questions or queries, don't hesitate to write it on the chat. I will try to answer during the presentation, or better at the end if you prefer. So we are going to continue, as you can see in this my screen, with this cycle of seminars. To our proposal is to introduce the OpenBeam workflow. And in this workflow, we are going to start always with a 3D model generated by any of the 3D models of the market, Revit, ArchiCAD, Allplan, etc., or even our IFC Builder free modeler that we introduced in the first seminar. We did it this month. And with this 3D model, you are going to store the modeling in the Bimserver.center platform. This is a free platform that you can register only with an email. You can register in this platform, and you can use it as a storage platform to to generate all your BIM projects. And you can also use it as a business opportunity to search for collaborators for any other projects in the platform. Also to like a store application to download and buy applications also, and to communicate with other people like a professional network. Okay, so we have many utilities and functionality of this platform, and the idea is to store the information of the modeling, the BIM modeling, in this platform and communicate with every specialized tools of the project design. We have developed, for example, civil engineering tools, MEP, lighting, acoustic, thermal dynamic simulation, etc. Fire protection, as today we are going to introduce and to show. And with these tools, we are going to generate all the technical documents of in project design, drawings, reports, cost estimating, specifications, etc. We are going to return the information to the BIM model, to the platform, and also in this format, with this platform, we are going to work in a collaborative, multidisciplinary, and multi-user way. And with this OpenBeam technology, we are going to use BIM format and in IFC format. So this is very useful because we guarantee the durability of the project. In the future, everyone is going to be able to open the IFC format in every software that's suitable to open this type of format. Okay. So this is the proposal, the OpenBeam workflow. Open is because it's based on standards, IFC4 standards based on an ISO code. And BIM modeling is we think this is the present and the future in project design. Okay, so once we have common a little bit the technology, the workflow we proposed, we are going to open the software, and we are going to generate or open a BIM project we have all created in the previous seminars. This is the platform, the Bimserver.center platform. You can register, you can log in. And I'm not going to explain a bit more because we have introduced the platform in the previous seminars. So this is the projects, for example, in the projects, the other day we generated a project for HVAC and for loads calculation. And here we have the files we exported the other day with the architectural model generated by IFC Builder, in this case, the free modeler. And we generated the calculations in the loads calculation and the HVAC calculations. We show the 3D view of these calculations. All of this is in IFC format and GLTF. This is a format to show the 3D view. And we have the information for layers for thermal model, for loads calculation, for HVAC, and the architectural model. If we hide a little bit, we will see the HVAC in this case, and all the information for thermal model and for the architectural model. So this is the project we are going to use today to export the information to our tool, fire protection tool. Okay, so I'm going to show you I'm going to open the suite, CYPE suite, and we are going to, I'm going to show you, well, I have two screens. Here is the aspect of the suite, CYPE suite, and here we have the OpenBIM tab, and we have the IFC builder. The IFC builder is the modeler, the free modeler we propose our users in order, if you work with Revit, ArchiCAD, or another BIM modeler of the market, you can avoid this phase, or you can use this IFC little software. Is very simple, but very useful to model 3D buildings in order to communicate with other tools. Okay, so in this case, we are going to use an office building. I'm going to open it because it's already modeled, and this is what we used the other day. And this is our 3D model, our office building. We have exported the information to the BIM project, as I showed you before in the platform. Okay, and we can update also the 3D view with this option, the update, and we can see also the information of all the elements and all the constructive elements and all the elements we have provided in another OpenBIM tool that we got the information returned here. Okay, so we use this 3D model. We have exported to the BIM project in the BIM platform, in the Bimserver.center platform, and we can update the information returned here. So also another tool important here is the synchronizer. The synchronizer is a free tool. You can install automatically with our software, or you can download it and install from the Bimserver.center platform. And here is to synchronize all the projects from my account in my platform, Bimserver.center, with the different tools. Okay, in this case, I have 4 projects synchronized. Today we are going to use Seminar HVAC. Okay, so this is very important to be this little application is important to be that is launched and also login with your account in order to synchronize the project. Okay, so let's move on and go to the suite again, and we are going to, well, as you can see here, we have different domains, specialties that we can cover in the project design, civil engineering tools. We have MEP tools, CYPEFIRE for thermal analysis, management for cost estimating, for example, Archimedes, documentation, and infrastructures. So today we are going to see this seminar is focused or meant to show the fire protection tools. We are going to see, first of all, the CYPEFIRE sprinklers, and afterwards a little overview of CYPEFIRE design. So CYPEFIRE sprinklers, this is an OpenBIM tool. This is obviously it's inside the OpenBIM workflow we showed before, and this CYPEFIRE sprinklers is meant to analyze and design sprinklers systems, networks of all kinds, for example, grid systems, mesh systems, loop systems, and it's based on a IPANET 2 engine. This is developed by American agencies, and it's meant to verify the compliance to the NFPA 13 codes. Okay, these American regulations for fire protection. Okay, so this CYPEFIRE sprinklers is integrated in the OpenBIM workflow, and we are going to show a little bit an overview of how to create a BIM project, how to import a BIM project, and how to make a hydraulic network design in this building. Okay, so we're going to create a new example, for example, seminar sprinklers total. Okay, we are going to accept here. We are going to all of the OpenBIM tools of CYPE have 2 possibilities of working. You can work with an import of a BIM model. This is the main utility, the main functionality we propose and we are promoting. And you have also always the second possibility is if you click no to this, if you answer no to this question, you can create a design, a hydraulic network without a BIM model. You can, from scratch, you can draw the spaces of a building, of a design, whatever design you want to create from scratch with DXF or DWG templates, or from scratch by coordinates. You can introduce the spaces and make the design of your hydraulic network. This is a possibility you have, but obviously the main utility of our tools is to import a BIM model in order to work in the OpenMig workflow. Okay, so we are going to select the project of my account. In this case, I'm going to search for the Seminar GVAC October. This is the project we worked the other day, and we are going to use today, take advantage of the model we have exported to this project. So we are going to read the BIM model. This is a 3D model, the architectural model. We are going to maybe, in this case, all the OpenMig workflow is meant also to detect clashes, interferences in the phase design. Obviously, on the screen you can see all the inconvenience or interferences between the different specialties you can detect in this phase design. So it's very important to import any other information of other OpenBIM tools to this design you are going to work on. Okay, so we are going to import the GVAC tool and loads calculations, and here you can search for typology of libraries you have worked in your folder. So if you have, this is meant to be, if you have worked already with the software, you can create your own libraries, for example, for sprinklers, for pipes, for hangers, for braces, etc. And you can use it as a folder of libraries in order to speed up a little bit the data introduction for this project, because you have already worked with previous projects and you can take advantage of this work you have already done it. Okay. In this case, I'm not going to search for typologies. I'm going to click next. I'm going to import all the stories of our building and all the spaces, all the rooms of our building. We are going to click finish and we are going to read the BIM model. Okay. In a short, we will appear the main window of this tool. So as you can see here, well, sorry about it. I'm going to activate the BIM model. Okay. So this is the 3D model. Well, maybe it's something about my computer, sorry about it. Well, I can enlarge the window in case you want to. Okay. Well, this is the window. This is the 3D view of the model. Okay. Well, maybe it's something about refreshing the view. I want to be the whole building. Okay, so well, let's continue. Here we have all the floor plans, all the stories of the building, and here we have the main graphical interface, the design area in order to create all the design of the network, the hydraulic networks, the pipes, and the sprinklers, and all the elements of the hydraulic design. So we have here the main toolbar of the software, of this tool. We have the general options project. We have the hydraulic analysis elements, pipes, fastening, reference drawings in order to make different plans, different drawings of different slopes, for example. Edit tools in order to move, erase, edit elements, all the elements of the design, the analysis tab, and the view tab. Okay, so we are going to start in general options. We can manage the general data of the project, which criteria formulation we want to provide. In this case, for example, Hayes and Williams. You can use the CYPE. Both are available with the software. For example, if you are going to make an analysis of liquids or fluids that are going to be with an anti-breeze, for example, you have to use the CYPE. Hayes and Williams is the most common way to analyze the pressure drops and their calculations in hydraulic networks. You can limit the pressure drops in order, if you want, or not, in case you can activate or deactivate, or another options in the design. Finally, this software is going to make it has the possibility to make the seismic analysis, but if you can activate or deactivate if you want. Okay. Let's upset here. Okay, I see a question. Someone's asking about this software, how to match our AutoCAD. Yes, you can Here, for example, in this case, you can manage your DXF or DWG templates. Here with this tool, with this DXF or DWG tool in the stores, in the floor plans, you can create your own templates. You can add templates in the DWG or DXF format, and you can import from AutoCAD or your CAD software. Okay. In this case, the templates are imported from the IFC model that is going to have been generated from the IFC builder. Okay. So it's possible to import templates in the DXF or DWG. So we continue in the general options. We have for the project data to configure the data for the project, and also the important thing before designing the hydraulic network is to establish the libraries. Let's start with the space types. Just we have to configure in order to establish the data for the design the space condition. So the space type we have to take one by one and establish the type of hazard, type of risk, and the construction type. According to the NFPA regulations, you can see here the type of risks, for example, with the help button, or the type of risk here, and the type of construction type here with this button. Okay, according to the Euro regulations. For the inner room, let's establish a light hazard, and for the offices and the meeting room, the main rooms of the building. For the water close, we are not going to install sprinklers, or not possible to install it in the lift either, and the risers either. In meeting room, it's possible to install sprinklers. In the corridor also, stairs are not going to be installed. Technical room is possible, and finally the terrace. We are going to avoid the installation of sprinklers. Every element for the different elements here, pipes, sprinklers, spaces, everything is suitable to be exported to a library. You can export and create your own libraries in order for future projects, and you can import it from another previous work you have done it with the software. So these icons is in order to manage your own libraries. Okay, everything is exportable of all of the elements in libraries. So let's create the sprinklers. We can create a sprinkler manually with the different options the software provides here. The K factor, the type of response, the type of the most common types of sprinklers. You can see standard, residential, ESFR, and also you can import from predefined values. For example, the most common values, I don't know, maybe for this typical project, for example, appendant sprinklers, we are going to provide here. So this icon, this arrow, is in order to import predefined values. So we are going to provide this pump and sprinkler, and the pipes we can create manually from a manufacturer, an industrial. All the data manually, size by size, and diameter or section by section. You can create your own libraries of pipes, your own materials, or you can import from predefined values. Here you have steel, copper, stainless steel, for example, in order to use in the software, or even, for example, a manufacturer, an actual manufacturer, we have imported here from Aquatherm. Okay, we are going to accept here the pipes. Also, you can configure your fire hose reels in order, if you want to provide an increase of flow in your hydraulic network, you can provide fire hose reels also. But the main utility of the software, I insist, is to design sprinklers networks. Okay. So for hangers, the same. You can create your hangers manually with your own dimensions, your own elements, or you can. This is the dimensions. The values it's demanded by the software, or you can import from a predefined library. Okay, so this is the loop hangers we are going to provide in the software. And finally, if you are going to provide a seismic analysis, you can create the braces and the fasteners. Okay, so let's accept here. So the libraries are already configured. So let's move on and then let's pass to the hydraulic design. Okay, so first of all, we are going to set the supply connection. For example, let's imagine that we are going to start from a supply connection for the public network. And here with the hydraulic design parameters, the pressures, according to the test demanded by the NFPA codes and the resident flow, we have to establish these parameters. As you can see here, are parameters introduced by the user. And always, always you are going to see this box with a box to introduce a value, and this lock, you can activate or deactivate the lock. And if you leave deactivated, the software is going to analyze automatically the box, the appropriate value. For example, maybe it's a value, maybe it's a reference, maybe it's a parameter, a size, a dimension, etc. Okay. On the contrary, if you don't find this lock next to the box, you have to introduce the value, okay, or the parameter, whatever. So supply connection, we are going to maybe set here the supply connection, and we are going to connect an horizontal pipe to connect to the hydraulic network inside the building. So let's a horizontal pipe. For example, we are going to establish the steel material, and we are going to make the, for example, 2.5 inches for the main, the cross main of this hydraulic network. Here, for example, all these parameters are with the lock, where they are going to be analyzed automatically by the software. Okay, the length design on the floor plan, the type of pipe, this is a branch or a cross main, etc., and the height above the floor. So we are going to connect or branch this supply connection in order to more or less the beginning of the building or the inside building in this room. Let's make an example design, a simple design of this dining room. So, well, the height above the floor, this value automatically set by the software, you can manage in every floor, you can edit and establish the sprinkler installation height by default. You can edit and modify whenever you want, okay? Anyway, you can edit a pipe or a sprinkler and modify the height above the floor if in case you want to avoid, for example, an obstacle or something like that. You can manage different heights in every floor, okay? So let's pass to the sprinkler positioning. So you can place the sprinkler manually. You can choose a pond sprinkler, for example, and you can position these sprinklers manually, as you can see here, or you can make with the different tools, branches, automatic branches, cross main with branches, or grid systems. So the software has different possibilities to place automatically a group of sprinklers. Okay, so let's erase these sprinklers. I have placed here. Sorry, this one. I'm going to deactivate the template because it's bothering a little bit. Okay, so this is the well, the dining room, and I'm going to establish, for example, a cross main with branches. A branch is something like that. For example, I'm going to show you. This is a branch. Okay, you can modify the size of the branches, the material, and also the spacing between sprinklers and the protection areas. Another thing that is important is the protection areas. Here, for example, if I place a sprinkler, I can establish manually the protected area. I can, for example, draw a protected area manually, or even if I have a group of sprinklers, for example, here, I can generate automatically a circular or rectangular protected area with the dimensions I want. For example, this group of sprinklers, 2 by 2 meters of rectangular protected areas. So you have many utilities to place the sprinklers, to generate the protected areas manually or automatically. Okay? So let's erase this example and continue with the real design. So we are going to provide in the dining room a cross main with branches, okay, with the panel sprinkler I hazard, rectangular protection areas, and the cross main is going to be, for example, 2.5, as we said before, and the spacing between sprinklers 2 meters, and the between branches also 2 meters. In this case, we are going to provide only a number of sprinklers, 1 and 1 sprinkler on the branch on the right and on the left. Let's start here, and as you can see here, well, maybe it's not very well placed, but it's enough for this example. Okay, more or less. This is how to make a cross main with branches, okay? So here we could add, for example, horizontal pipes, or I don't know, 1.5 of branch. I can here add another branch here, and another one, for example, here. Okay, and we could add a sprinkler over there and over there. Okay, so if we can add also manually a protected area. If I can, for example, I can add a protected area here and another one here. Okay, for example, let's more or less in this way, with this design, more or less real, you can see that more or less we try to cover the whole space, the whole dining room, in order to cover the protection. Okay, so we are going to save the changes. Well, you can manage here something in the configuration, general configuration of the software. You can manage the units in which you want to work with. For example, you can work in an international system or an IP system. Okay, you can both work with systems, or even you can work manage or change the units individually. You can change the unit one by one, and the accuracy also you can modify the decimal digits. Also, you can modify the background color, the undo redo options, and the automatic saving options. Every 5 minutes, you can automatically save if you want. Okay, for example. So in order with this design, let's try and make an analysis and update results and see what the solver is going to tell us. Okay, and here, for example, it's showing the solver is showing a warning that pipes are disconnected from the installation and have been disconnections in the hydraulic network have been detected. So the design is full of errors because the solver is detecting that something is not well connected. Okay, so if we see, for example, in the information of each pipe, I see the height above the floor is 0 meters in this case, and here I made it on purpose, and the height above the floor from here is 2.70. Okay, in the height installation by default. So I have to establish here a pipe, a vertical pipe. Okay, let's establish this vertical pipe. Okay, I can establish a reference if you want, and 2.5, for example, in a steel, and let's establish here. So this is the vertical in order to change the height. Okay, so let's update results. Okay, so the warning has changed. The connection between the network is already established. And for example, here the software is telling us that we have forgotten to establish the operating areas or the protection areas. The operation areas in the design scenarios. So the software cannot analyze or size the pipes according to the hydraulic analysis. Only is taking into account the design and checks for the geometrical for the geometry or for the space rooms. Okay, so here, for example, the software has analyzed the automatic geometrical installations or the geometrical verifications according to the NFPA codes, and only we have an error here, and it's telling us that it's left the operating area because this is the worst case sprinkler. You will see maybe I'm going to deactivate, for example, the protection areas, and you will see this circle, the white circle, indicating that this is the worst case sprinkler for the hydraulic network. It should be included or inside the operation area. Okay, so let's activate the protection areas. We will do it in a minute, but let's see the geometrical verifications. If we activate the console checks here, we can click on the sprinklers and we will see the verification for geometrical analysis, the maximum allowable protection area, the maximum distance between the sprinklers, the minimum, and from walls and from sprinklers, according which point and which paragraph or section of the NFPA 13 codes. Okay, this is very, very good and very useful because you can see in just a window all the verification, all the points of the regulations. Okay. For example, if I'm establish, I don't know, maybe if I move, for example, this, I'm going to make an error here. If I move this sprinkler to this point and I update results, we will find an error, and the minimum distance between the sprinklers is not verified. You see, because they are too close one to each other. Okay, let's undo and come back to the previous state. Okay. Let's update the results. Okay, so once we have seen the, okay, someone is asking about, well, water curtains protection. No, not yet. We don't have it. This option, I don't know if it's very common, that type of protection, but here in the software, at least for the moment, we have sprinklers system and fire hose reels, not water curtains. Maybe it's a good suggestion or improvement to take into consideration in the future. I will take notice of it. Okay. So we have, for example, well, let's add the design scenario, the area of operation, in order to make the hydraulic analysis. So we are going to create the area of operation, and the areas of operation, the regulations establish different criteria. Is something according to the is something that it depends on the criteria of the user, really, and you have to design yourselves which is the area of operation you want to work with in this hydraulic network, which sprinklers you want to consider opened in the moment of a calculation. For example, let's establish these 5 sprinklers as the worst case, or the worst sprinkler we want to consider in the hydraulic network opened. So let's update results, and you will see this warning or this info that is telling us that hydraulic analysis has been carried out correctly. Okay, and you can see here that is no error appearing here. There's no mistakes, no errors here. So the hydraulic analysis has been considered properly. So let's consult the checks. For example, we can consult the checks in the sprinklers. Well, this is the geometrical, sorry. We can really consult the checks in the, for example, in the pipes. In the pipes directly, we can see all the characteristics of the parameters, the flow, the pressure, losses, the velocity for each pipes. And also in the spaces, we can consult, we can click on the, well, I want to show you the results for, yes, here we have, no, sorry. Okay, I want to show you the verifications, okay. Okay, well, let's see the reports here. Well, what technical documents we are going to show in we can obtain with the software. We can obtain the reports project here with all the verifications. Okay, so here you should start or obtain the project hydraulic analysis and the flow test summary test and all the nodes and pipes with the different parameters: flow, velocity, initial pressure, final pressure, etc. Okay, so this is all the calculations from the NFPA code from with our hydraulic network. All the reports you can share it by internet in PDF format. You can export it in docx, HTML, TML, text format, etc. You can print it in paper directly. You can print it in a PDF format. So there are different formats you can establish. Also, the drawings. Which drawings you can obtain here? I'm going to show you. Here we are going to, for example, only we are going to establish the scale, and we are going to only establish the ground floor. For example, we are going to deactivate the DXF. We can manage here the title blocks, the layers for exporting to CAD software. And here we have the detail. Well, we have a legend here. We can move it and include it in the main, the same plan, the same drawing. And here we have all the design with the sizing of the tools, of the different pipes, the different nodes, and all the sprinklers included in this, and the area of operation. Okay. What else can we do, for example, with the software? Instead of having a supply connection, we could have, for example, let's erase here, and we could have a tank with a pump, for example. Let's provide a tank here, for example, and also a pressure pump. Okay, here we can provide the different pressure curves manually, point by point, or by a midpoint. This is allowed by the InPanage engine, or you can import predefined pumps in the future. Well, it's a wish to have different manufacturers or industrial or brands, specific brands that are going to be included here as a particular from manufacturer. Okay, so this is a centrifugal pump, for example. We are going to provide here. Okay, and we are going to connect the horizontal pipe, okay, with this pump. Okay, so if we update results, well, something is disconnected. Okay, sorry, it's the vertical, the pipe. I'm going to replace it. Okay. Yeah, I'm going to connect here and here. Okay, perfect. Update results. Okay, and everything is analyzed. Here, well, the worst case sprinkler maybe is something here because we have included a tank. Okay, and also the tank is sized by the software. For example, you can introduce manually or force it or block it, but you can size by the software. If you size the minimum, and we can solve the checks according to the NFPA 13 codes, we can supply the minimum time indicated by the NFPA 13 minutes, and with according to this risk or this hazard, this is the minimum capacity. Okay. So, well, we could add, for example, the design for different floors. For example, we could introduce another, well, I can show you in order to use, if you want to see, for example, floor 3, we can provide from ground floor, I can establish a horizontal pipe here, and I can connect from here, for example, to a vertical pipe. Okay. Vertical riser from the ground floor just to the floor 3, for example, and I can provide it here. Okay, so if we move to the floor 3, okay, I will see here the riser, and I can connect a branch and horizontal pipe just up to here and up to here. So if I introduce, for example, a branch, I don't know, with these parameters. Okay. Okay, this is unreal, but it's just an example. And I can design a scenario from the area of operation, for example, only this tube. Okay. So if I have the results, okay, the hydraulic analysis, well, obviously there are errors that the software is indicating that the space is not properly covered by the protected areas. Okay, so we can here also we can see with the design which data we can consult. For example, in this case, this is what previously I wanted to show you. For example, here the hydraulic analysis, I can consult the text and all the verifications on the screen. This is what I wanted to show you before: the minimum operating pressure, the sprinkler operation, minimum flow, etc. All obtained from the regulation. Obviously, this is all going to be included in the project reports, but you can see here. Okay. So this is the design. So let's see now the 3D view. Well, here is not very well seen. I'm going to open the 3D view. Okay, let's pass the screen here. The whole 3D view of the building. And as you can see here, this is the tank with the group pressure and all the design of the pipes. And just for inside, for example, I'm going to deactivate the beam model, and this is the piping of the sprinklers and each sprinkler in each room with the representation in 3D. Okay, this is the riser, just to the another floor 3 in order to complete this room. Okay, so as you can see, it's very simple just to use. It's very user friendly, and here you can detect interferences in between, for example, HVAC or this equipment is clashing with the, for example, with the HVAC with the fire protection sprinklers network, which is something that is shouldn't happen, obviously. And you can detect and manage all your interferences in the phase design. It's very used. Okay, and in this case also another clashes, another interferences between this internal unit from the BRF, for example, HVAC, and the pipes for network sprinkler network. Okay, so what else can we obtain here? For example, very useful is the material list. The material list is for sprinklers all the quantities of the estimating for all the quantities elements for the steel materials, for the pipes, tanks, pressure groups, and obviously sprinklers. And you can obviously export in different formats, and also you can export in VC3 format. This VC3 format is a standard format for communicating with cost estimating softwares in many countries. For example, let's generate the VC3 material list, the quantities, and we are going to import it in Archimedes. Archimedes is our cost estimating software, and you can manage your quantities from this design. For example, in file, I'm going to import this bill of quantities from this fire design. For example, seminar sprinklers, and the software is going to import the currency. I can establish the currency, the different currency we can manage here. For example, I don't know, in dollars maybe. And here you can see all the different parts of different elements: sprinklers, pipes, tanks, and pressure groups. And here all the quantities. This is very tough to do it manually, and the software is going to automatically estimate the quantity of the different elements. And you can add here the rates and the cost estimated to obtain the budget, the execution material budget. For example, I don't know, $25 for each meter, for example, or I don't know, for each sprinklers, $400. This is not real. It's something just to make an example. Okay, and finally, you are going to obtain the estimate of the whole sprinkler design. Okay, so this is another utility, another functionality of CYPEFIRE sprinklers. You can export to your VC3 format and communicate with Archimedes in order to complete the cost and estimating budget of your sprinkler design, your hydraulic network. Okay, so I think it's more well. You could add here, for example, the loop hangers. We have the hangers, and also we can establish, I don't know, maybe a hanger here and another one here, for example, and we can update results and see the checks. In this case, the diameter of the pipe is very fine. I have to activate here and modify the diameter of the hanger. The same thing for the other one. Okay, and here you can consult the checks according to the NFPA regulations, the same as the other points of geometrical points to the sprinklers, the calculation for hydraulic pipes, and you can update results in order to modify. If we refresh the 3D view, we will see the hangers also in the 3D view, and we can also estimate and make the quantities of the hangers. Okay? Okay, so this is more or less the main utility of the software, how to create a hydraulic design. This is, the flow test, the hydraulic analysis, and all the elements from the hydraulic network. Okay, So this is more or less the, well, here there is an error of the tank. We must update the capacity or the volume of the tank. Well, okay. So more or less is the definition. Well, to end with this tool, we can export the information in ISC format in order to return the information to the project, to the BIM project. So we are going to export, for example, here. Well, first of all, we are going to activate the graphical analysis, for example, for flow, and you can see on the screen. Okay, you can see the flow, in which points, which parts of the flow is higher or lower, as you can see here in this this bar with the different units or the different values. Okay, so sorry about it. Okay, so let's export the information to the BIM project. Okay. Wait. Okay. Let's graphical analysis of the flow, for example, and the information of the ISC. Okay. So now the synchronizer should be in a minute. Should be synchronized. Voila. This is synchronizing the project, and it's exporting to the cloud, to the platform, the Bimserver.center platform, the information of the sprinklers. So let's open the platform. Sorry, the Bimserver.center platform. Let's refresh, and here we will see it's internet. My internet connection allows me to show you. Yes, files. Voila. This is the sprinkler information in IFC, GTF of the different elements for the 3D view, and in the 3D view of the project, in the OpenBIM project, we will see the information for the sprinklers added to the one that was previously included in the software. Well, let's deactivate the architectural model, and here we will see all the information for the sprinklers, network, and obviously the HVAC design. Okay, so this is the idea to the project. Is all the tools are returning the information to the BIM project in the platform, and the sprinkler design, HVAC, etc., lighting, etc. All the information should be returning to in ISC format to the BIM project. Okay, so this is, well, the explanation of the overview of the CYPEFIRE sprinklers. And to finish with the, well, let's see shortly the CYPEFIRE design tool to finish this seminar. Well, the CYPEFIRE design is not included in the main suite of CYPE. This is not here, the CYPEFIRE design. You can download it from the store of the store application part of the Bimserver.center. Here in the store, you can search it. Sorry, CYPEFIRE, and here you have the CYPEFIRE design. Okay, you can download it and install it in your software, and you can buy here or wherever. So this is the software. You can search it, and here you can download it to install in your PC. So I have, well, let's open the CYPEFIRE design. Okay. So this software, I'm going to show you because I have it in the other screen. Well, okay. So this software is meant to create or to verify the fire protection safety compliance according to any regulations all over the world. The users can create or the verifications or the compliance according to any regulations worldwide. You can configure your own codes, your own regulations manually. The idea is to include by default regulations from time to time. For the moment, we have the Moroccan regulations. In the near future, we will have the French regulations, and we hope to have more regulations for different countries. But for the moment, you can create your own regulations, okay? And the idea is to verify, for example, the compartmentalization zones, the limitation for outdoor propagation, the means of evacuation for occupancy, protection facilities, the access for firemen, for firefighters, etc. So I'm going to open, for example, an example. Okay. Another example here, for example, this is an office building for the Moroccan regulations. Okay, this is more or less similar to the. This is the 3D view of the building. I'm going to show you here. Okay, this is the 3D building, more or less the office building we have been projecting in the seminars. Okay. And the idea is, well, this is the aspect and the environment, the graphical environment is very similar to file, for example, to the previous one we have seen for CYPEFIRE sprinklers. We have the 3D view here on the bottom left of the screen. We have the different stories, the different floors of our building. The BIM model here imported from any BIM modeler. We have generated the IFC. And here with the main toolbar divided in project tab, compartmentation, evacuation, protection installations, and outdoor propagation. So, for example, in general options, we can configure our regulations. The general adjustments, for example, the minimum access roads, minimal maneuver spaces, in order to, if you want to consider the spaces, the minimum spaces for engine, for firemen or for firefighters. Maximal level occupancy of the building, for example, if you wanted to, you can configure it manually. Also, which design options you want to configure. For example, you want to verify only the occupancy evacuation, or besides the protection installations, or the firefighter intervention. You can configure the three of them, or both of them, or whatever you want. Also, with fire resistance, you want to consider the minutes for fire resistance for each element, for the reference, and according to your regulations. Okay. In this case, for example, for Moroccan regulations, we have established 60 minutes for fire resistance. Okay. Also, the spaces, the space occupancy, we can create the density for the people. According to the square meter, you can establish the density of occupancy. Okay, you can create as many spaces of occupancy as you want if you have different uses in your building. And here you have to create your own checks. For example, for different zones, you can create, for example, for occupancy zones, you can create for offices building what is going to be included in the zones. For example, fire extinguishers. I can create the properties, the minimum properties, for example, pulverized water, potable, and the capacity. Obviously, we can add many verification regulations according to the codes you are verifying. For example, according to the verifications according to the evacuation height, you can establish the limits for the different fire extinguishers. Or, for example, you can add, for example, detection systems for your building. And you can configure that different according to the area below the ground level or the number of floors. You can provide the detection system mandatory according to the number of floors of the building, for example. So this is something that is customizable by the user, and you can configure your own regulations. Okay. So you can configure the zones, the risk zones, the safe zones. For example, the evacuation paths. For example, here. Which with checks you want to configure, for example, according to the occupancy, the minimum width, for example, to 100 people, it's going to be 1.50 width for the evacuation paths. So this is a table you have to configure it. And here also, next to each regulation, each verification, you can establish a description of the regulation. For example, I don't know, Spanish standards, paragraph 1.23 from regulations. I don't know, and it will appear in your regulations of the project. Okay. Here everything is exportable, as you can imagine, to the libraries. You can export and create your own libraries, your own regulations. Here you can define your equipment. For example, fire extinguishers. Or from Moroccan regulations, we have defined different extinguishers with different properties and different symbols. Okay. You can do the same for example, for detection systems, the symbols, etc. And here always can always import the regulations by default for in this case for this flag. This is Moroccan. As I said before, the idea is to include or improve with different countries, but for the moment you can do whatever you want here. Okay. So you can import the different regulations according to the type of building and according to the different regulations for Moroccan properties. So once you have provided the general options and the definition for spaces, and you can create your own zones. Here you can create your zones for the forest building, and every parameter is going to be analyzed by the software, the volume, the surface area, because it's going to be taken from the BIM model. Okay. And finally, here, once you have defined all the zones, the stairs, the lifts of your building, you have to create and assign to each element. All the rooms and the spaces of the building, you have to create and assign to each zone, each risk stairs, elevator, lift, etc. This is something you have to create. For example, this is a stair I have created here, and all the rooms for the stairs that's here, I have attribute or assigned to the stairs with this icon, with this element. Okay. Well, what else could we do? For example, define the evacuation routes. As you can see here, we have defined for each room, or for each floor, we have defined the evacuation routes. Okay. And every element is going to be analyzed automatically by the software. We have to attribute the evacuation route typology of the library, and we consult the checks according to the regulations we have established in the library's typologies and the general options for the job. Okay. So once you have configured all the elements, for example, here, let's generate here an error. I'm going to force the width of this element, for example, for 1.75, and we are going to block here, and if you cancel the checks, we will not comply the minimum of the regulations according to the people that he included here. Okay, if I calculate here, the software is going to be analyzing all the verification, and it's telling us that the minimum width of this evacuation route is not complying the verifications of the regulations we have provided. Okay. If I edit again and deactivate and block this element, we are going to size again, and everything is compliant again. So if we, for example, here more the same thing. For example, in the general options for the maneuver spaces, the width, for example, minimum 6.5 meters according to the, I don't know, Indian codes 0.745, well, 7.3 regulations of the code. Okay, if I verify the compliances, an error is going to be appear because the width of the maneuver space we have we have designed for 5 meters and is less than the minimum allowed according to the verifications that are established in the general options. Okay, so I can edit here and modify with 6.7 meters. Okay, and update the results and clear. Okay, so we can obtain here the results reports with checks according to the regulations. Okay, here we have all the regulations established in the general options. Something is here, everything, because there are not many regulations in this type of building, for example, according to these codes. And also the project reports also. Well, I'm going to pass with this window, zones, stairs, and all the different verification and description regulations for each point of the regulation. Okay, as you can see here. Obviously, all the projects, the quantity of verifications, the quantity of the size of the reports, it's depending on the regulation, the verifications you are going to define the general options tab. Okay, so this is the complexity. And finally, the material list. Obviously, the same thing, the same way as fire sprinklers, we are going to be a material list of the extinguishers, fire extinguishers, the quantity, the alarm buttons, the detectors, fire alarm control panels, alarm systems, all the elements we have provided in the different floors, of the building, all the alarm systems, alarm buttons, the evacuation routes, etc. Okay? And also we could export the information in ISC format, return to the project, to the main project, update the results, and also obtain the drawings floor by floor, and we are going to show you a scale, the different, for example, evacuation, equipment, and accessibility in DWG or DXF format. No? And in this case, we are going to show the different elements with the legends and all the routes, evacuation routes, all the position of the different elements, fire protection, safety, for each room of the building. Okay? We could export also the same way to BC3 format to acknowledge, to accumulate all the elements that are suitable to generate a quantity survey. Okay? So, more or less, that's it. Well, this is because I thought that it was more important to explain better the CYPEFIRE sprinklers, and this is only a little overview for CYPEFIRE design. They are related, obviously. For example, if CYPEFIRE design is going to provide in any of the zones that you have provided a sprinkler system, there is going to be a requirement appearing in the CYPEFIRE, in the OpenBIM workflow, in the BIM project of the Bimserver.center platform, that in CYPEFIRE sprinkler you should design an hydraulic network of sprinklers to that room, or that zone, to this building. So they are related in between them. Okay. So, well, I think I finished with the explanation of the fire protections seminar. If you have any queries or any questions, okay. I see some questions. Sprinklers, bill of materials including pipe, elbow, steel? No, not for the moment. In CYPEFIRE sprinklers, we don't have special pieces or special connections. In the general options tab, we provide for the pressure drops, we can increase a coefficient to take into consideration the special elements of a hydraulic network for sprinklers, but not for the moment. We don't have the possibility to measure the quantities of these special elements. We hope, maybe it's a wish in the future, we will see a way to do it, maybe. It's a wish. Maybe some manufacturers, some industrials is going to be included in the software. We could have all these special elements of the special T, elbows, connections. Maybe it's a wish we have. We can include it. Anything else? Any questions? Any more questions? Everything is more or less clear. This overview of the fire protection tools for fire sprinklers and for CYPEFIRE design. Anyway, if you have any questions in the future, you can ask our colleagues of the Sales International Department, Vincent or John Paul, or you can write an email to our support@cype.com technical support department. So do not hesitate to test the software, to consult every query or question you want to ask us. And I encourage you to test the software and to ask us wherever you want, whatever doubts or queries you have. Okay. So if it's not any more questions, well, we finished today with the seminar. Let's see you again to the next seminar. It will be on November, I think.
Next Friday.
Next Friday.
Plumbing.
For site plumbing. Okay. So thank you for your attendance to this seminar today. I hope you found it interesting, and see you next day for the next seminar. Have a nice day and bye bye.